Hello everyone, this is Mr. Harper, and we're going to continue our discussion on blood today. We've talked about the parts of blood, red blood cells, white blood cells, platelets, plasma, and what each part does. And today I want to turn my attention to a little bit of a different topic, and that is blood typing. Now you probably know that you can be type A or type B or type A, B, or O. And you also probably have heard that some people can donate to some people and other people can't, and there'll be interactions, and somebody receiving the blood, wrong kind of blood in a transfusion could suffer a reaction. And I want to explain a little bit about that and try to demystify why can certain people donate to who and other people not. And to do that, we need to start with the immune system, because it's the immune system that is causing this problem. And so let's talk about that and talk about antigens and antibodies to set the stage for what we need to get to. So an antigen is a fancy term for something that can trigger an immune response in your body. For example, the COVID virus. You've heard that the COVID virus has like this little hook thing on it that you can use to get into cells. Well, the hook is an antigen. Antigens are proteins on the surfaces of blood cells, surfaces of cells that can trigger immune responses. You have antigens on surfaces of cells of your body, and if those cells got into someone else's body, the immune system would recognize those. The antigens that you have, your body recognizes as normal, but it's abnormal if it's in someone else's body. So anyway, we'll get back to that. So antibodies are defensive proteins that your immune system makes in response to antigens. And each antibody specifically attaches to only one antigen. They fit together like a lock and a key. So if this is the antigen, the lock, the key is the antibody. Now, so cells have chemical markers on their surface called antigens. Here's a cell, and these little things that stick out are antigens. You have antigens on the surface of your cells, and your immune system recognizes those antigens as you and says, oh, that's me, that's okay. But if your cells got into somebody else's body, like maybe a blood transfusion, your blood cells, then there could be antigens there that other people's immune systems recognize and go, oh, that's not right, and attack. If you get a virus, like maybe this is the COVID virus, maybe these little things are this like hook, except this one's not shaped like a hook, but these are antigens that cause your immune system to respond. Cells that get infected with a foreign substance like a virus can display an antigen on their surface of their cells that tells the immune system, hey, come and kill me because I'm infected and I'm going to die, or I'm going to cause the body to be infected. So come and kill me and kill the things in it, all with it. So these yellow things are antibodies, and your cells, your immune system cells, make these antibodies that fit like a lock and a key onto each antigen. And antibodies can attach to two antigens, causing the cells to clump together so your blood cells can come and attack them. So here's an antibody, this purple thing. The yellow thing, orangish thing, is an antigen. And here's this cell that's displaying the antigen. So each antibody can hold on to two, so it's holding on to this one and this one. And then this antibody can hold on to two, this one and this one. And you can see how they begin to clump together. So the purpose of an antibody is not to kill the thing, but is to attach it together and then alert the immune system, hey, we got a bunch of these foreign cells here to come for you to come and kill. And there are other cells that actually do the killing. So let me give you a practical example of this. So let's assume that, go back to this one, that you get this into your body. It's a foreign invader. Maybe it's a cold virus. Maybe it's the COVID virus. Maybe it's a bacteria. The bacteria that causes tetanus, maybe. So you get it into your body, and you've never had it in your body before. Your immune system looks at it and goes, hey, wow, did you see that antigen, that foreign-looking thing over there? We better make an antibody to attach to it so that the immune system can kill it. So your immune system goes off and works on creating this antibody. While it's creating it, these things are growing in your body. They're replicating, they're dividing and making new ones, and you're sick. Your immune system eventually makes enough of the antibodies to attach to these things, to round them up all together, so the immune system can come and kill them, and you get better. Now, let's say that happens. Your immune system then leaves some of these antibodies that they made in circulation in your blood. If you ever see this thing again, your body doesn't have to go and make this thing again. It's already figured out how to make it. It took some time to make the first one, figure out how to do all that. But the second time around, they already have some and they know how to make them, so they quickly make more, and they kill the thing so quickly that you never even get sick. You never even knew you had the thing. And this is the basis of immunity and the basis of an immunization, like an injection against the COVID virus, for example. They're giving you this piece, this antigen, or something that looks like this antigen, that your cells then make this piece, or excuse me, the immunization has this piece in it, and your cells see that piece and make antibodies to it. But because it's just this little piece, not the whole thing, it doesn't make you sick. But your body will make the antibodies to attach to that thing. And then the next time when you actually see the real thing, you've already figured out how to make it the first time, so that from then on, it's easy to figure out how to make more of them and kill the thing very quickly, and you don't get sick. So that's the basis of immunizations, of vaccinations. All right, so let's move on. Now, in your blood, you have 4 blood types. You have type A, type B, type AB, and type O. Here's your red blood cell. That's what determines your blood type. If you're type A blood, you have this little antigen on your blood that we call type A. You notice this one's like a circle. If you're type B blood, you have a different kind of antigen. This one we've represented as a triangle, and it's different. Actually, a diamond. What am I saying? And it's different. You look, it's shaped differently. These two are. So that's type B blood. If you're type AB blood, you see what you have. You have type A and type B antigens on the surface of your blood, red blood cells. And if you're type O, you don't have any antigens at all. One type of blood is not better than the other. They're just different. All right, they're just different. Now, this is your red blood cells. Now, antibodies present. Antibodies are floating in the blood plasma, the non-liquid part of blood, or the liquid, part of blood. So here's what happens. If you have type A antigen, you have type B antibody. You have the antibody for the antigen you don't have. If you have type B antigen, you have type A antibody. If you have type AB blood, you don't have either antibody. And if you type O blood, you have both A and B antibodies because of these antigens. You can't have the same kind of antigen and antibody in your body, because if you do, the antibody will attach to the antigen and try to kill it. I shouldn't say kill it, attach it and clump it together so that the other parts of your immune system can kill the thing. So, if a person is given a blood transfusion of the wrong blood type, it can cause what's called an antigen-antibody reaction and cause your blood to clump, because those antibodies are going to hold the blood cells together. So, here's the rules. If you're type A blood, you have an A antigen, B antibodies. You can get blood from people that are type O or A, and you can donate to A and AB. If you're type B, you can see what you have there and who you can donate to, O and B, and get blood from B and AB. If you're AB, you see the antigen and antibodies you have, you can get blood from O, A, B, and AB. This is called the universal recipient. They can receive blood from everybody, and they can only donate blood to other people that are AB. O blood doesn't have either antigen, or it has both antibodies. It can only get blood from other type O people, but look who you can donate to. O, A, B, and AB. This blood is called the universal donor. There's also something you've probably heard it said before. You're A positive or A negative or O positive or O negative. There's a negative and positive, what's called an RH antibody. We'll talk about that more later. So just a little bit of a taste here, and we'll talk more later on what this chart really means and why it's the way it is.